Hi everyone, my name is Ing Sarah and I am a senior in chemistry major. I've been working in the Freudian lab and doing computational chemistry research since the summer after my freshman year, back when I first joined the PURE program. Back then I had no idea what computational chemistry was and how we could apply that to photochemistry or anything at all. I had some background in Python, but very little to none in programming, but it's safe to say that I could barely code. However, the main programming language you would need to know would not be Python, but rather Linux, which is not quite a language either. It's more of a command that's mostly written in C language, at least at Lehigh University. With no experience in programming or understanding quantum mechanics, I was extremely overwhelmed in the first week of training. And here's what my first day experience looked like. First and foremost, the computational training, Intro to Mubarak's term or terminals. Looks like something complicated that we usually see in the sci-fi movies with a bunch of commands that you need to memorize. Even creating a folder can be intimidating if you could not follow the instruction properly or you're spaced out. And a typo in the command can lead you to somewhere you don't expect or you can't exit from. If you feel too bad to ask the grad student mentor or your professor every minute you try to work on a calculation, I recommend looking up Linux command for beginners and save that within Rage for convenience sake. Print it out if you could. And after 2 weeks of practicing or working on a beginner project, you will remember most of what you need to know to run basic calculations. However, it's always a great practice to ask for help and clarification, which can be a great opportunity for you to connect with your professor or your graded mentors, or even discuss with your peers to connect with them will be great as well. Second, Gauss view program with the molecules that never move the way you want them to. This is not a normal, fun graphic program that you're supposed to be familiar with since day one. It takes time to be comfortable with it. Even I got rusty after a few weeks of not using it, and please remember you can always ask for help because that's what we're here for. Third, DFT and TDFT. Density functional theory. What on earth is even that? I only finished Gen Chem. That was pretty much my thought on the first day when DFT and TDFT were constantly mentioned, like constantly, because they are a key behind these amazing calculations we'll be analyzing throughout our computational chemistry study. Whenever they pull out the equations like this, I don't know about you, but that usually was the time I started to space out. I remember back then I watched a quantum mechanics video that tried to explain DFT and TDFT with my friend. It took us 3 hours to get through the video, and we're both left with pretty much nothing. The takeaway is it is okay to not understand it right away. Everything will start to connect once you get into it, but it will depend on time, familiarity, and practice. I did not take quantum mechanics until my junior year, so it is okay to feel like you don't know what you're doing, especially in the beginning. Well, enough about the struggle. Let's talk about motivation to learn computational chemistry. Why is it so awesome? As you can see, computational chemistry can achieve study that can be done in the wet lab, but takes way less time and resources such as drug discovery, material science, and chemical reactions. Moreover, it can also achieve some information that cannot be observed in a traditional lab, such as geometry optimization of the molecules or molecular and reaction dynamics of complex molecules. Computational chemistry is basically computer calculations that incorporate theoretical chemistry, like DFT and TDFT, quantum mechanics, and programming to rationalize and predict the structures, reactivities, and other properties of molecules or chemicals. With better designs of efficient quantum chemical algorithms and AI over time, we can explain and explore known and unknown or new chemistry that could take way longer to acquire the data or conduct experiments in the wet lab. It can be extremely challenging for everyone to learn. Even I was struggling a lot in the beginning, but remember that you're not alone and there will always be people and resources that could help you out. Best of luck. Bye.